Hey guys, this is Miss Mo. My title got cut off, but it's supposed to say 3.1 edition. And at the beginning of this, it's kind of wonky, but after that, it's just a bunch of different ways that we teach kids how to add. And when you add, you probably only use one of these ways, but you have to remember when you're a teacher, your job is to differentiate and change how you teach so that every single person can conquer the material. So even though there's probably 20 different ways of adding in here, your students will pick one that they really like and they'll probably use that for the rest of their life. And I'm pretty sure some of us did not go over this type of adding when we were a kid, but that's okay. Okay, so first 3.1 starts off with some old school math, just about rules and logic, kind of. We talk about properties. The first property is called commutative. Yeah, okay. And it just says that you can rearrange. A plus B is B plus A. That means when it comes to math, like 1 plus 2 is the same darn thing as 2 plus 1. Hot dog. Hot dog. You can just rearrange when it comes to plus signs, and the sum will be the same. So 1 plus 2 is 3, and 2 plus 1 is 3. That's called commutative. Okay, let's look at associative. Associative means that basically you can move the parentheses. So if you look at what is written, it says A plus B plus C, A plus B plus C. Yeah, that looks great. The only thing different is the parentheses move. So in a second, we're gonna have to identify whether it's commutative or associative. And if the parentheses move, it's associative. If the actual things move, they get rearranged, it's commutative. Okay, and then I think you know the rest of these. Okay, let's look at this sucker right below. It says, state the name of the property illustrated. Okay, well first let's see if any of the numbers were rearranged. I have 8, 4, 7. And then I have 8, 7, 4. Those have been rearranged. So that's called commutative. Good. Okay. Commutative. Now let's look at the parentheses. And the parentheses here are kind of different. They're more like brackets, like square things. But let's look. Looks like I got a square thing around 4 plus 7. And then let's see, did the square things move on either side of the equal sign? Nah, bro. Those square things, yeah, they're around different numbers, but they literally have not moved their physical location. We have on the left 8 plus brackets. On the right, we have 8 plus brackets. Okay, so the only way this would be associative is if the brackets moved. Maybe on the right side, the 8 and the 7 were in the brackets. That's what associative would be, if the brackets moved. But so far, just the numbers moved, so that's commutative. Okay, let's look at the next sucker. It says, show that the following are true by using the properties. What the poop? What? Okay, so this is saying the XYZ and the ZXY, no matter which way you add them, you still get the same thing. Okay, as in, they are supposed to be the same thing on both sides. So what we're going to do is we're just going to show that they are the same things on both sides. So first, let's see. Let's check that associative. Did the parentheses move? It looks like they did not. But look at what's inside the parentheses. I have a y plus z and an x plus y. Those are not the same things inside. So something happened associatively. Let's look at this last example. inside those brackets, there was a 4 and a 7, a 7 and a 4. So those things were the same on the inside. So it's not associative there. But if we look at ours, are they the same inside the parentheses? Nah, man. Okay, so they're not the same in the parentheses. Let's see if we just rearrange some stuff, because those are the only properties we're really using right now. Rearranging numbers or rearranging parentheses. So ask yourself, what did I rearrange? The parentheses or like the letters? And it looks like the letters got rearranged. So when the letters are rearranged, that means it's commutative. Yes. But at the same time, let's remember, associative is if your parentheses move or if the stuff inside changes. Well, let's look inside our parentheses. We have a y plus z and an x plus y. Those are different. So we also have associative. So this first one is associative because the inside of the parentheses change, and commutative because the letters all rearrange themselves. Okay, let's look at this next one. First, let's check to see if the letters are rearranged. We have XYZ, YXZ. Yep, those are rearranged, so it's definitely commutative. Yes. Okay, let's check the parentheses. We got a Y plus Z and an X plus Z. Those are not the same things, so it's associative. So, because my letters rearranged, it's commutative. Because the things inside the parentheses changed, it's associative. Okay, let's look at this next sucker. The answer is actually over here on the left. So if we get confused, we can just look over here on the left. Okay, it says, give reasons for each of the following steps. Use the given list of reasons on the right and enter the appropriate letter next to each step. So these are a bunch of rules, and we have to decide which one of these rules applies to which line of math. Okay, well first, let me remind you that place value Hui, that's that 10 to the 0, 10 to the 1, 10 to the 2. Yeah, that's that thing with the tens in it. So anytime we see tens or converting something to using tens, it's probably place value. Okay, associative was the parentheses have to be different. Let's see, commutative was we were rearranging. And then I think after that, everything else we can kind of do. Okay, so let's look at this first line. It looks like they changed 33 to 3 times 10, which is 30, plus 3. What? Okay, well that right there is nothing but place value. All they did was change that 33 to 3 times 10 to the 1, plus 3 times 10 to the 0. And 10 to the 0, we don't always have to write it. And 10 to the 1 is just 10. So it's supposed to look like 3 times 10 plus 3. And that's what it did look like. Okay. So this first line is G, place value. Okay, let's look at how we get from the first to the second line. What happened? It looked like what's inside the parentheses are now totally different. And let's look at the order of everything. On the top line, we have 3, 10, 3, 3, 10, 6. On the next line, we have 3, 10, 3, 10. Something's out of order. Do you see it? So this first line has 3, 10, 3, 3. The second line has 3, 10, 3, 10. Okay, so not only did we have the associative, because the parentheses change from one line to the next, but the order of the letters also changed. So from this first to second line, the parentheses changed and the order changed. So see, what's inside the parentheses on the first line compared to the second line is not the same. So that means the parentheses changed, as in associative. Then, since the order of the numbers change from the first to the second line, see, we have 3, 10, 3, 3. On the second line, we have 3, 10, 3, 10. Those are different. So that means commutative. But if you look at the answer key, it doesn't say A and C. Instead, it says D, because D says associative and commutative properties of addition. So instead of listing A and C separately, you just say D. Okay, then on the next line, what does it look like we did? Let's see here. It looks like the 3 plus 6 is the same, but it's this first set of parentheses that changed. It looks like the 3 plus 3s are still there, but it's like they took the 10 out. See how instead of writing just 10 twice, they wrote it once? That's called the distributive property. Okay, then how did we get from 3 plus 3 to 6? That's just single digit addition facts, H. And then the very last thing, how do we get from 6 to 10? 6 times 10 to 69? Well, that's that place value thing again, since we have the times 10s. And this question won't be on a test, so don't panic. And if you need the answers, they're right here on your little chart. Okay, after this, it should be pretty simple. Okay, let's look at one way to add things up. Okay, this is called partial sums. And some of us actually do this in our head already. Some of us have never seen it before. Okay, it says you add vertically one column at a time. Don't forget to leave a blank placeholder for every new line. So 9 plus 5 is 14. Then they move on to the next line. 6 times 4 is leave a placeholder and put 10. I meant to say 6 plus 4 is leave a placeholder and put a 10. Then we have last vertical. First, we got to put 2 placeholders now. Then 5 plus 6 is 11. And then from there, you add up normal. So let's do that here. We're going to add the first column. 8 plus 9 is 17. Then we're going to add the second column. 9 plus 4 is 13. But remember, you got to keep that placeholder. Then lastly, 7 plus 5 is 12. But don't forget, you need 2 placeholders. Okay, then we're going to add up and down. So 7 plus blank blank is 7. 1 plus 3, 4. 1 plus 2, 3. And then this leftover one, we just bring it down. Hey, isn't that crazy? Check it. This is actually how you can add. Okay, so that's called partial sums. You just add each up and down column one by one, and you use placeholders. Now let's look at this lattice adding. I really like this. It just makes me feel fancy. Okay, lattice means you still add up and down, and we still write our numbers down, but we fill in these little diagonal places. Let me show you what I mean. So first what we do is we take this first column, 8 plus 3 is 11. So we put 11. Then we go to the next sucker. 9 plus 4 is 13. And you put a 1 in the top left, 3 in the bottom right. Then 7 plus 6 is another 13. Then lastly, 1 plus 7. Instead of putting 8, we're going to put 0, 8. So if you have a single digit, put a 0 before it. Then the very last step is to add the diagonals. So 0 plus something, 8 plus 1, 3 plus 1, 3 plus 1, 1 plus something. So let's see here. 0 plus nothing is 0. 1 plus 8 is 9. 1 plus 3 is 4. 1 plus 3 is 4. 1 plus nothing is 1. And then your final answer is 9441. And we drop that 0 on the very left because we don't need it. Okay, let's do one where we have to draw it ourselves. Okay, so 5478. Let me go ahead and put it on top of each other. 2895. Draw like some boxes. I think I got it. Oof. Okay, now let's add up and down. 8 plus 5 is 13. 7 plus 9 is 16. 4 plus 8 is 12. 5 plus 2 is 0, 7. Then we're going to add up all of our diagonals. So 0 plus nothing is 0. 7 plus 1 is 8. 2 plus 1 is 3. 6 plus 1 is 7. 3 plus nothing is 3. So my answer is 8373. And we drop this 0 on the very left.